entire weeks of Unit 6 into about 20 minutes. Some of you may not make it through the entire video, but we will remember you and your bravery. You're going to be fine. Okay, so we started at Unit 6 by learning how to take the square root, and we started in Unit 5 talking about solutions, finding solutions by graphing, like how many times it crossed the x-axis. So we're going to do that same thing here. Let's start by graphing. We have y equals 2x minus 8. Couldn't I rewrite this as y equals 2 times x minus 0 squared minus 8?
I mean, you could, yeah.
Okay, is it then obvious what the h and k are?
Yeah.
What are they?
2's the 8. Wait, no.
That's the a.
That's what I missed. I missed the A, not the H.
Okay, the 0 is the h.
Right.
And negative 8 is the k. So my vertex is down here at 0, negative 8. Okay, then I'm going to use my pattern to find some more points. So it goes 1, 1. 2 squared is 4. 3 squared is 9. But what do I have to do to those points?
Multiplying by 2.
Multiplying by 2, my a value. So that turns into 2, 8, and 18. So from my vertex, right or left 1, up 2. Start at the vertex again. Right or left 2, go up 8, where we hit the x-axis. And then my other points are going to be way up here. Way up here.
Way up there.
Ooh, that was lumpy.
Way.
Okay, so you can see very clearly that I have two beautiful x-intercepts. My x-intercepts are negative 2, 0, and positive 2, 0.
Right.
These are the x-intercepts. So that's what we knew how to do from Unit 5.
Right.
Okay. Then in Unit 6, we started learning how to find those points where we cross the x-axis. We learned how to find them algebraically. The first one was taking the square root. So we had to set the y equal to 0 because those are the points we want. They have y's that are 0. Okay. If we're taking the square root, we're trying to get the squared part alone. So we're isolating x squared. You need to go to the nurse. Okay. Do you want to go rinse off in the bathroom? Why don't you take a fistful of tissues? Okay, you've got some on your hand, just be careful. Okay. All right, so we're trying to isolate the squared part. So the first thing we can do is add 8 to both sides. So that'll give us 2x squared equals 8. Then we can divide by 2 on both sides. Get x squared equals 4. How do we undo squaring? Square root. Now you can see that we have two x-intercepts. This is why we have to allow for the square root to be either positive or negative, because it can cross twice. Okay. Because either negative 2 squared is 4 or positive 2 squared is 4. So my x's are negative 2 and positive 2. These are the roots, the zeros, the solutions. Notice that they are the x-coordinates of the x-intercepts. They are the x values that make the y value 0. So if I know my x-intercepts, I can find my roots. If I know my zeros, I can get my x-intercepts. They basically give us the same information.
Right.
The difference is that these are solutions that go in curly brackets, and these are points in parentheses. Okay? Okay. Next, we started doing intercept form or factored form. So we used the ZPP. We said that if our y value was 0, we would have to multiply by 0 to get a 0 as a product. Right? We have to multiply it by 0 to get 0. Otherwise, there's no way to get 0. So either x minus p or x minus q must be 0 to make our equation true. So this is how we did it. We made our y 0. We saw that there were two factors. We set each of those factors equal to 0 to find the x that makes it 0, that makes the y 0. So we do 2x equals 0 and plus 5 equals 0. And we solve them both. Divide by 2. We get x equals 0. Subtract away the 5. We get x equals negative 5. Those are the roots. All coming back?
Yeah.
Okay.
Could be.
All right, sometimes we had ones that looked more like this. We still had to make the y 0. This time I have 1, 2, 3 factors. I set each of them equal to 0. Does negative 3 ever equal 0?
No.
Okay, that's a garbage one. What about this x? What would x have to be to get?
3.
Yeah, it has to be opposite, right, to cancel a positive 3? And for this one, I can add away 3 to both sides. So that gives me 2x equals positive 3. And then divide by 2. And I get x equals 3 halves. So my solutions are x equals negative 3 and 3 halves. And if I were to see what this looked like, graphing, on Desmos, which you will be able to use for the EOC, I have one root at negative 1, 2, 3 right here, and the other one is at 3 halves, which is 1.5 right there. My A value was negative 3, so this is going to open down and be stretched. So it's going to be very steep and go like this. So if I gave you this problem on the EOC prep, could you put this in Desmos, find the x-intercepts, and then give me the roots? Yes. So at the beginning, we're going to go through all of this stuff and remind ourselves how we did things the long way, right? And then when you're doing this on your own, if you want to do it the long way, great. It's great practice. But what I would encourage you to do is think about, how can I use my understanding of the long way to use Desmos and be strategic and sneaky?
Right.
Okay.
Exactly.
Yeah. So I'm not expecting you to do everything the long way. Okay? All right. You guys are doing great. Let's keep going. Next, we are factoring completely. So the first thing we need to look for when we're factoring is a GCF. So what number divides evenly both 6 and 18, the biggest number?
6.
6. Okay, how many x's do they have in common?
What?
I've got 3 and 2. How many can come out? 2. X squared comes out. How many y's can come out? 1. Okay, then I need to find the leftovers. To find the leftovers, I have to divide each term by my GCF. Sixes cancel. What power of x is left? 1. Okay, what happens to the y's? Cancel. Bring down the plus. 18 divided by 6 is? What happens to the x's? How many y's are left? 1. Parentheses are a little too big. So this is my leftovers. Okay, now look at my leftovers. Do I have a trinomial where I can find magic numbers? No, I have a binomial. 1, 2.
Right. Oh.
Okay.
Yeah.
Do I have any factors that remain that I can factor out? Okay. Do I have a difference of squares that I can use some factoring pattern on? No. So I'm done. Done. All right. Look at number B. 4B. There's no equation. I'm just factoring completely. So what's my first step? GCF. What is my GCF? 2. Can I take an x?
No.
Okay. So if I divide everything by 2, I'm left with x squared minus 1x minus 6.
Right.
Now I have to look at my leftovers. Do I have a trinomial to factor? Okay.
Yeah.
So remember that we multiply to our c value, -6. And we have to add up to our b, which is -1. So this is our c and this is our b. B goes on the bottom, c goes on the top like a cap. Okay. What do you think? 1, 6, 2, 3.
Well, you can do negative even. I know. You do 2 and
2 and -3. Good. So that would be x plus 2 times x minus 3. And what do I need to make sure that I bring down in the front? 2. Because if I multiplied and distributed all of this back together, I should get what I started with. And I can't get that without my 2. I have to have it. 2 is one of the factors that needs to be listed.
Right.
Okay. Are you okay? All right, next page. Anybody want to cry yet?
Only a little bit.
Only a little? Okay.
I'm ready to go home.
Oh, man. I was really hoping to make somebody cry today. All right, what about this one? Now I have an equation. In order for all of my tricks to work, so in order to use all of my tricks, boys, in order to use all of my tricks, I need to have everything on one side in standard form and a 0 on the other side. So the 9x is going to go to the other side where it's negative. The question is, do I put it in the front, the middle, or at the back? Middle, because it's going to be my bx. So I've got 3x squared minus 9x minus 30 equals 0. Is there anything I can divide away? Divide everything by 3 on both sides. So then I get x squared minus 3x minus 10 equals 0. Now what?
Then that's where you get like the -10 and then the -3.
Okay, magic numbers. So factors of -10 that sum to -3. What are they? -5 and 2. Good.
Nice.
Okay, now what am I ready for? I've got my beautiful factors set equal to 0. What property?
I don't know property, but no. I know you have to do.
The zero product property. Le zipipi. Oui, oui. All right, so that's x plus 2 equals 0 and x minus 5 equals 0. Can you do this part in your heads?
Possibly, yes.
Okay.
It's x equals -2, but
Correct. -2, positive 5. Okay, so we can start with a trinomial in standard form, factor it, use our ZPP, and get our roots.
right.
The next question wants us to start with the roots, write an intercept form equation, and then go to a trinomial in standard form. So we're going to go backwards. So we're starting at the end. If the roots are 2 and 5, that means that x equals 2 and 5. What would the intercept form equation have to look like? Look at the signs. +2 minus 2. -5 plus 5. What would I have to get a 2 and a 5 right here? A -2 and a -5, okay? So that would be y equals x minus 2 times x minus 5. Now you know why our intercept form looks like this. X minus p times x minus q. It has to be opposite to get a 0,
Right.
right?
Mm-hmm.
If I put a p in here, p and minus p cancel, right?
Yes. Yeah.
If I put a q in here, q minus q, cancel. It's a 0.
Yeah, this is done.
Okay, you're mocking me, but it's amusing,
I'm not mocking
so I'm
you.
laughing with you.
I'm agreeing with you. I'm
Okay.
remembering this.
It's just that exciting, huh? All right. We're blowing minds in here. Now, how do we turn this into standard form? How do we get rid of parentheses? Distribute. There it is. Okay, so that would be y equals x squared. And then x times -5 gives us -5x. -2 times x gives us -2x. -2 times -5 gives us +10.
Right.
Okay, we have like terms. Pew, pew. And we get y equals x squared minus 7x plus 10. Done. So, if they give us an equation, we can solve it for our roots. If they give us roots to start with, we can build an equation using our intercept form and convert it into standard form.
Mm-hmm.
This equation will have those solutions because of the factors.
That makes sense.
Okay. Mission accomplished. Next page. Or next problem.
This one.
All right, tell me about dimensions. What are dimensions? What are we looking for? The measurements of what?
No.
Yeah, what measurements for the rectangle do we want? For area, what's an area? Length and width. The dimensions are the length and the width. Okay, and we know that area equals length times width. Area is our product. The length and the width are being multiplied together to make the product, therefore they are the factors. What would we have to do to a product to find its factors? What process? What process would undo distributing? What? Say it again. Close. Factoring. We have to factor. Remember, this is one of our direction stems that mean factor. All right, do we have a GCF to divide out?
No.
Okay, almost, but the 4 ruined everything.
Right.
So we can't divide out the 3. All of our factoring tricks require an A value of 1, so we're going to have to slide the 3.
Oh, the slide and divide, right?
We're going to slide and divide. So that gives us x squared minus 4x minus 45. Now what? Factor, we are looking for magic numbers. So we want factors that multiply to negative 45 and that sum to negative 4. Anything that ends in a 0 or a 5, I'm thinking 5. 5 times what? 5 times what? 9. Tell me about the signs.
Negative.
Negative on the 9. Good. So now I have x plus 5 times x minus 9. But I did a slide, so now what? I have to divide. I can't leave it. I have to divide by the 3 I slid. Does 3 go evenly into 5? No. So bottoms up, it becomes the coefficient of my x. All right, what about 9 over 3? Becomes 3. Good. So now I can just pick one to be the length, one to be the width. I have my area factored into 2 dimensions. All right, we've officially made it through 3 weeks of our 6 weeks of Algebra 1, Unit 6. Whoa.
That wasn't supposed to happen.
No, that was not supposed to happen.
Oops. Sorry, it happens to the best of us.
I was having the most trouble with this earlier. I don't know why it shrunk on me. Okay. Okay, here we go. So after we did factoring, guys, the next thing we learned about was completing the square. Everybody's favorite. Oh my goodness, I'm struggling. Okay, what are our requirements for completing the square?
I don't know, I can't remember.
Okay, what can you tell me about the A value? The A value must be? No? 1. Okay, what about the B that we have to chop in half? Does anyone want to chop in half an odd B? No. So our B has to be even. Okay, those are our requirements. Let's go. Let's go. All right, first, do we have standard form set equal to 0?
No.
Okay, we've got to get it then. So we're going to have to subtract away the 12x. Are we going to put it at the beginning, the middle, or the end?
The middle.
The middle. Okay, next, divide out a GCF. Is there anything we can divide away and make our lives easier?
3.
3.
Divide everything by 3.
Divide everything by 3.
Even the 0.
Even 0, especially 0.
Mm-hmm.
X squared minus 4x minus 8 is 0.
You have to get the magic numbers.
Not yet.
Oh, not yet. My bad.
Okay, it says we have to get rid of the old C value. Our old C value is the negative 8. We're going to add it to the other side. So that'll be x squared minus 4x. We're going to leave room for our new C value. And then on the right side, we'll have 8 plus our new C value. Does anybody remember how we get our new C value?
I forgot.
Am I allowed to answer?
Yeah.
Isn't it like B divided by C times A?
It's
No,
close.
2 times A. 2 times A.
It's close. Okay, we take the B and we chop it in half.
Yeah.
And then what do we do with it? Okay, nobody knows. We square it. So negative 4 chopped in half is negative 2. 2 squared is?
Negative 4. Or 4.
4.
Or negative.
Whenever we add our new C value, it would be positive because regardless of whether we're squaring a negative or a positive, we get a positive. Okay. Now we have made a perfect square trinomial. And we have to factor it to make a squared binomial. So we want factors of 4 that sum to -4. Remember, they should match. -2 and -2. Bada bing, bada boom. All right, now we can write our squared binomial. So that would be x minus 2 squared equals 8 and 4 make 12. All right, guys, now we're home free. How do we undo squaring?
Square root.
Square root.
Square root both sides.
Both sides, plus minus. Okay, unit 2. Put on your unit 2 hat. Is there a perfect square factor hiding in 12? I got on my unit 2 hat.
2,
Yes.
4.
Oh.
So this is plus minus root 4 times root 3. We know the square root of 4. That's why we wanted it. What is it? 2.
Booyah.
Booyah. Okay. The square root undid the squaring, and our x minus 2 has been liberated from the parentheses. Hallelujah. What is the very last step in getting x alone? Add the 2 over to the other side, which gives us x equals positive 2 plus or minus 2 root 3. Final answer.
Golly.
Whew.
We're gonna slip. Oh, that was pretty epic. Good.
No, now I'm shy. That was a good one. That was better than mine. Mine lacked some spirit.
No, yours is
Really quick, yeah. All right. We've talked about square root. We talked about the ZPP. We factored our faces off. We did completing the square. What's left?
Sorry, what? My bad.
All right. Can we solve this by factoring? Well, let's check. Can I divide away a 3?
No.
Okay, let's slide the 3. Check for magic numbers. Are there factors of -15 that sum to -1? 3 and 5? No. Okay. No factoring.
Yeah.
Don't worry.
What about completing the square? Is our a value 1?
No.
Okay, do we have an even b?
No.
Oh my gosh. If only there was a formula that works on everything.
Quadratic.
The quadratic formula. Yay! Okay, it is on your reference sheet. X equals the opposite of b plus or minus the square root of b squared, whoops, minus 4ac, the whole thing over 2a. Now, do we have standard form set equal to 0?
Yeah.
Okay, thank you, math gods. They smiled on us. What is the a value?
1? Oh, no, the A, oh, my bad.
The other a.
3.
3. What about the b?
That's 1.
What
Wait.
kind of 1?
Negative.
-1. Good, just watch your signs. What about the c?
-5.
-5. So now we just plug it in. Okay, so x equals, if our b is negative, what's the opposite of it?
Positive.
Yeah, positive. Plus or minus square root. Okay, when you plug in your b squared, don't forget the parentheses, or you will be in a world of hurt. Okay, minus 4 times my a times my c. The whole thing over 2 times 3. Okay. Now, you don't have to compute all of this by hand. Your calculator will do this whole inside bit for you. Okay, Okay, 4 times 3 is 12, times 5 is 60. Negative 1 squared is 1. I'm getting 61. Oh yeah, 61.
Oh, yeah.
Okay, does 61 have any perfect square factors?
No.
No.
Then, my friends, we're done. This is it. Remember, if it's really, really gross, you don't have much simplifying to do. Okay, so that was the hard way to do everything, right? Okay, so now when you go back and you work on the rest of your packet, I want you to think about the tricks that we discussed with the hard way. Like, where do we find the intercepts? Like, how can we rearrange things? Where can we divide out and like factor things? And use Desmos. And don't work so hard on the rest. Okay, be sneaky. Go.